Hello geometry students. In this video we're going to work through our Unit 9 practice quiz in preparation for the real quiz that will take place in class next time. So let's take a look at number 1 that asks us to sketch the line of reflection. So if you're going to have a reflection, there has to be a line of reflection. And so I'm going to sketch a line of reflection, and then we'll check that line of reflection. Here's how we know if I've drawn it correctly. So choose a pre-image point and an image point, and then if I were to draw a segment that connects those 2 points, then my line of reflection should be the perpendicular bisector of a segment that connects any pre-image point to an image point. So that's all there is to number 1. So let's take a look at number 2. Now number 2 says, notice carefully what the directions say, sketch and label the line or the reflection in line M. So we're going to take this quadrilateral, we're going to reflect it in line M. So if you were to do that point by point, let's start with point B. So I don't know why I picked B, but that's where I'm going to start. So what I need to do is place point B such that, let's place it right about there, such that the segment that connects B to what will be B prime should be a segment that is being perpendicularly bisected by the line of reflection. So that's where B prime would be, and you'll do that for the rest of the points. I'm going to go ahead and stop the video and draw the rest of this. Okay, so hopefully your reflection looks something like this. Couple things to note. First of all, these little dotted lines are not required. I just drew them to help me try to ensure that M would be the perpendicular bisector of the segment that connects a pre-image point to an image point. So your reflection should look like this, but I just want to point out that if you leave your answer like this on the quiz, you will not get full credit because directions say sketch and label the reflection. So make sure that you label each one of these image points. So this would be point A prime, this is point D prime, this would be B prime, and then C prime. So make sure that when you do a reflection or any kind of transformation, make sure that you label the image points so we can indeed see that it is a reflection. All right, so let's take a look at number 3, and I want to point out that I'm going to add something on the real quiz that I did not put on this practice quiz, and that is the following. I'm going to give you some points. I'm going to go ahead and give you the coordinates of points P and then Q and R. So let me stop and do that. So you will be given the coordinates for P and Q and R. Those are the pre-image points, and then you'll be asked to find the coordinates of the image points P prime, Q prime, and R prime. So to find those coordinates, use the transformation that has been described. Here we're doing a reflection in the x-axis. So if I'm going to take a point like point P and reflect it in the x-axis, that will happen when we take the opposite y value. This point will have the same x coordinate as P, but it'll have the opposite y coordinate. In other words, that rule is xy becomes x, the opposite of y. So in other words, P whose coordinates -4 and +1 will become P prime, which is -4, -1. And then Q, whose coordinates are -2, +5, will become -2, -5. And then R, whose coordinates are 4, 3, will become 4, -3. So you'll find the coordinates, and then you will plot those points and sketch the reflection. Be sure to label your reflection. So I'm going to stop the video and do that. Okay, so when you sketch your graph of P prime, Q prime, R prime, once you have plotted these points, you should be able to see the reflection in the line in the x-axis, the line which is the line y = 0. So now let's take a look at number 4. This one asks us to sketch and label the reflection in the y-axis. So again, let me stop the video and give you the coordinates of the points W, X, Y, and Z. On the quiz, those will be provided for you. So on the quiz, you will be provided the coordinates of the pre-image points, and then you'll be asked to find the coordinates of the image point. So let's start with W, whose coordinates are -3, 2. Now, if I'm going to take that point W and reflect it in the y-axis, if W is going to be reflected in the y-axis, well, to flip it over to the other side of the y-axis, we'd have to change the sign on X. In other words, each pre-image point, XY, will become opposite of XY. That's how we'll flip it over the y-axis, or in other words, reflect it in the y-axis. So that means that W will become W prime, whose coordinates will be +3, -2. X prime's coordinates will be +4, +3. The coordinates of Y prime will be +1 and 4. And then Z prime will have coordinates +1, -2. So I'm going to go ahead and stop the video. I'm going to graph those 4 points and label them, and then draw the reflection in the line in the y-axis. So your reflection should look like this. Again, by plotting the coordinates of these points, you should be able to see the reflection in the y-axis. And then I just want to remind you again, make sure that you label your image points in order to get full credit on the quiz. All right, so let's move on to number 5, where again, let me go ahead and provide you with the coordinates of the pre-image points L, M, and N. Okay, so here are the coordinates of L, M, and N, and so what we're going to do is reflect in this line, the line y equals x. So you'll recall from class that the rule for reflecting in the line y equals x is just take your x and your y values and switch them. We talked about the fact that a reflection in the line y equals x is what we call an inverse function, where you take the domain and the range values and they just switch places. So that means that point L, 0, -2, will become L prime, whose coordinates would be -2, 0. We just switch that x and y. The coordinates of M prime will be 3, 2, and the coordinates of N prime will be -1, 5. Again, we found those image points by just taking the coordinates of the pre-image and switching them. So let me stop the video and plot these 3 points. And so once you have graphed these image points, again, you should be able to see the reflection in the line y equals x. All right, so let's take a look at number 6. Now, number 6, when you take your quiz, you will have access to patty paper. So, excuse me. So what you'll want to do is on your patty paper, you'll want to trace the pre-image triangle ABC. Then on your patty paper, put a point at the tail of your vector that determines the translation. And then if you slide the point on the patty paper, if you slide it from tail to tip, what effect that will happen is it will move every one of these points the same distance in the same direction. So I don't have access to patty paper on this iPad, so let me just see if I can carefully sketch. What I'm going to try and do is mimic this vector movement for A and B and C. I'm going to take A, B, and C and move them the distance and the direction determined by vector K. So, and this is going to be freehand, so it's not going to be perfect. So I'm going to start with A, and I'm trying to match the length of vector K, and I'm trying to move in a path that's parallel to vector K. So that looks pretty good for A prime. Okay, and then let me slide B the same way. I'm going to try and mimic the distance and direction determined by vector K. Okay, so B prime would land right about there. And then C, same thing. See if we can mimic that distance and direction. Okay, and I think you'll have better success with this. Whoops, let me change to a pen. Here we go. When you're able to use patty paper. So well, that's not too bad for a freehand drawing. But if you leave your answer like that, you would not get full credit. Make sure that you label every image point. So the name of this point would be A prime, the name of this point would be B prime, and the name of this point would be C prime. Okay, so now let's take a look at number 7 that asks us to sketch and label the translation along. Remember, this is how we indicate a vector in component form. Notice these grouping symbols, these pointy grouping symbols. That tells you you're looking at a vector. So these are not the coordinates of a point. These indicate a horizontal change and a vertical change. So what we need to do is take these x values. We're going to increase all the x values by 6. And then we'll take each of these y values and we'll decrease them by 4. All right, so again, on the quiz, you will be provided with the pre-image points, and you'll be asked to provide the coordinates of the image points, and then you'll graph those points. So let's start with P. If we are going to translate point P along the vector 6, 4, then P prime would be positive 2, negative 3. Again, what I did is I took my I took my x value and I added 6 to it to get the x value of the image point, and then took the y value of the pre-image point, subtracted 4 from it since this is a negative 4 to get the y value of my image point. So then Q prime would have coordinates positive 4, positive 1, and R prime 5, 0. So I'm going to stop the video and plot those points. All right, so when you have plotted your image points, plotted, and be sure and label the image points, you can check just to let's take, for example, P. I'm going to translate it along the vector 6, negative 4, which means it will have a horizontal change of positive 1, 2, 3, 4, 5, 6, and then a vertical change. It's negative, so I'm going to go down 1, 2, 3, 4. So you can check that with all your points, and you can see that every pre-image point has been translated along the same vector 6, negative 4. Problem number 8 asks us to determine the vector in component form that translate triangle STU to triangle S prime, T prime, U prime. So pay attention, make sure you notice which of these triangles is the pre-image and which one is the image. This one is the pre-image because its coordinates don't have primes. And then we know that this one is the image because you'll notice every coordinate name has a prime. Okay, so if I want to write my answer in component form, first of all, it's going to look like this. It's going to have grouping symbols that are kind of pointy. Okay, this first component will be a horizontal change. So let's just see what happens as we travel from S to S prime by first making a horizontal move. If I need to get to S prime from here, I'm going to make a move to the left. 1, 2, 3, 4, 5. So I move to the left 5, and I'm going to have to move up 1, 2, 3, 4, 5. And that was in the, since we went up, that would be in the positive direction. So my vector in component form then would be negative 5, indicating the horizontal movement of 5 units to the left, and then a positive 5, which indicates my vertical move. Let's say I move 5 to the left, and then my vertical move up 5 units. And that's all there is to that one. Number 9 asks us to sketch and label a 90-degree rotation about point P. So we're going to take this triangle and we're going to rotate it 90 degrees in the counterclockwise direction. That's to the left, counterclockwise direction, about point P. Okay, so we're going to do this point by point using the definition of a rotation. So let's start with point L. So what I'm going to do is I'm going to draw a segment that goes from L to the center of rotation, and then what I need to do is to determine where L prime should be. Well, L, P, L prime should form a right angle. So I need to know that L is going to be somewhere along this segment that makes a right angle with segment LP. So I'm going to just roughly sketch that. You can use the corner of a piece of paper to help you get a right angle, or maybe use a corner of a piece of patty paper. So I know that L prime needs to lie somewhere on that blue segment, but the other part of the definition tells us that the distance from P to L should be congruent to the distance from P to L prime. So it looks like, and again, I'm just eyeballing this, so maybe right about here is where L prime would land. Okay, so let's do the same thing with M. So I need to draw a segment that is perpendicular to this red segment or forms a right angle. And again, using a corner of a piece of paper will help you get that angle right. And then my distance from P to M should be the same as my distance from P to M prime. So it looks like M prime might land right about here. That's not quite where it should go. I think it needs to be a little bit farther out. So maybe more like here. So that would be M prime. And then let's do the same thing with N. So I'm going to draw a segment from N to P, and then I need to form a right angle. Okay, so it looks like maybe right about here makes a right angle. And I need my distance from P to N to be congruent to my distance from P to N prime. So N prime ought to land right about here. All right, so now I'm going to connect the dots and get my triangle. Now, the way you can check this with a piece of patty paper is place your patty paper over point P and over the figure that you're rotating. Trace that figure and then put your pencil point at point P and rotate the paper 90 degrees or a quarter a turn, and you'll be able to check how you did. Mine isn't so great doing a freehand drawing, but one thing you might want to also use is you could use a ruler and measure these segments to make sure that you are getting them the right distance from your center of rotation. Okay, so now let's take a look at number 10. So again, I'm going to stop the tape so that I can provide you the pre-image points. So in number 10, we are going to take these pre-image points and we are going to do a 270-degree rotation about the origin. So the rule has been provided for us. If you're going to do a 270-degree rotation about the origin, just take your X and Y value, you're going to change the sign on X, and then you're going to switch them. So XY becomes Y negative X. So that means if our pre-image point D has coordinates 1, 2, change the sign on X and then switch them. So D prime would have coordinates 2, negative 1. E prime would have coordinates 4, negative 1. F prime would have coordinates 4, negative 5. And then G prime would have coordinates 2, negative 5. So again, I applied the same rule every time. I just changed the sign on X and then switch them. So I'm going to stop the tape and plot those points. And after you have plotted your image points, you can check your work by, again, using a piece of patty paper. Trace quadrilateral D, E, F, G. Put a pencil right at the origin, which is what you're rotating about, and then a 270-degree turn is a 3/4 turn, so rotate that patty paper 3/4 or 3/4 of the way of a complete turn, and then you should see how the image corresponds with what you've traced on your patty paper. Just a reminder again, make sure that you label your image points, because that's how we know that you've actually done the rotation correctly. All right, so let's move on to take a look at number 11. Let me stop and set this one up for us. So in number 11, we're going to do a composition of transformations. We're going to do a glide or translation followed by a reflection. So we'll translate along the vector negative 7, 3, which means there'll be a horizontal change of negative 7, left 7, and then a vertical change of 3, meaning we'll move up 3. After we do that translation, then we'll do a reflection in the line y equals x. So let's go ahead and do the translation first. Again, this is component form of a vector, which tells us that how you change your x value and how you change your y value to get your image point. So we will start with point W, whose coordinates are 3. Oops, there's a mistake here. That should be 3, negative 5. So I'm going to take my x value, I'm going to decrease it by 7, so 3 minus 7 would be negative 4, and then take my y value and increase it by 3, so negative 5 plus 3 would be negative 2. Then we'll do the same thing for x. increase the x or decrease the x value by 7. So 2 minus 7 is -5, and then increase the y value by 3. So -2 plus 3 is 1. All right, and then for y prime, we're going to decrease 5 by 7, so that would give us -2, and increase -1 by 3, which gives us +1. And then z prime would be -1, -1, because again, we've increased or decreased the x value by 7 and increased the y value by 3. So let's stop and plot and label those points. Okay, so here's the image after the translation along the vector -7, 3. I did have to make a correction. You probably caught this. Y prime, I had made a mistake here, and you catch these mistakes when you go to graph it. This y value shouldn't have been 1. -1 plus 3 is actually 2. So let me fix that. That should be +2. Okay, so you should see that we have first on the translation, we took every point, we rotated it to the left 7 and then up 3. All right, so now let's perform the reflection. We're now going to reflect this quadrilateral in the line y equals x. So you'll recall from an earlier example that reflecting in the line y equals x, all we need to do is to take our x and y values and switch them. So if w prime is -4, -2, then w double prime will be what we get when we just switch those. So it would be -2, -4. Then x double prime would be +1, -5. I'm just switching the x and the y. Y double prime would be +2, -2. And then z double prime, well, -1, -1 just doesn't, nothing happens when you switch. So let me stop then and plot those points. Okay, so when I plotted these 4 points, I changed the color to blue so you could see, hopefully you can see the reflection in the line y equals x from x prime, y prime, or w prime, x prime, y prime, z prime. Reflect that in the line y equals x, and we get, oops, I'm missing w prime. Let me label that. This is w prime, or w double prime, and then x prime, y prime, z prime. You can see the reflection y equals x. So again, on the quiz, you'll be provided with the coordinates of the pre-image point, and then you'll be asked to find coordinates of your first transformation followed by your second transformation. Okay, in problem number 12, we are asked in each of the following to describe a single transformation that would map point B onto point B prime when the figure is reflected in a line N followed by a reflection in line Q. So in other words, we're going to take this shape, we're going to reflect it in the line N, and then we'll do a second reflection in the line Q. So this would be a composition of 2 reflections. So you'll recall that we learned in class that a reflection in N followed by a reflection in Q, that double reflection over parallel lines, we could accomplish the same thing with a single transformation. That transformation would be a translation. So what you'll need to say on the quiz is you'll need to say that it's a translation, but then you need to keep going and tell us in what direction. Well, it's either going to be up, down, left, or right. In this case, that translation would be down. And then tell us how far you translate. You've given the direction, now tell how far. And that distance will always be twice the distance between the 2 parallel lines that you are reflecting in. So we need to take 3/8 and double that. So you could either call that 6/8 inches, or you could call it, you could reduce that and call it 3/4. That either answer would be fine. Okay, so that composition of translations in parallel lines results, you could get the same result by doing a single translation, tell the direction, and then how far. All right, and then number 13, same thing. We're going to talk about what a single, if we were to reflect this quadrilateral in line N followed by a reflection in line Q, we can accomplish the same thing by a single rotation. So you'll say that this would be the same as a rotation. Tell how far you rotate. Well, remember, how far you rotate is always going to be twice the measure of the angle formed by the 2 intersecting lines. So since that angle is 25 degrees, then the rotation would be 50 degrees, and then tell what you're rotating about. That would be about the point P, which in this case, or in every case, is the name of the point where the two lines that you're reflecting in. It's the name of the point where those two lines intersect. All right, and then numbers 14 through 18, we're going to refer to this regular pentagon. Make sure you know that it's regular. First thing you're going to ask or answer is this question: does the pentagon have line symmetry? In other words, could we draw a line such that if you were to fold the paper along that line, one side would line perfectly up or line up perfectly with the other side? And the answer to that question is yes. So let's circle that. And then 15 asks us to sketch all lines of symmetry. Well, there would be 5 lines of symmetry. What you're going to do is you're going to draw a line of symmetry through each of these vertices. So here's one line of symmetry. One line. I'm going to change colors so you can see these a little better. Here's a second line of symmetry. And then let's see, a third line of symmetry. And then 4. And I'm kind of running out of colors here. I'll do yellow. And then 5. So those are our 5 lines of symmetry. So you'll be asked to draw lines of symmetry. Number 16 says, does the pentagon have rotational symmetry? In other words, can I rotate this shape about its center, and if the shape maps onto itself in less than 360 degrees, then you'd say yes, it does. So I would recommend that you use a piece of patty paper, trace your shape, okay, find the center, and then start rotating the paper and see if it maps onto itself. If it does in fewer than 360 degrees, then you would say yes, it does have rotational symmetry. The order of symmetry is how many times it maps onto itself. Well, if you would perform this experiment with patty paper, you would see that this pentagon maps onto itself a total of 5 times. And then to find the magnitude would be how many degrees do you have to rotate the paper until it rotates onto itself. So to find that, just take 360 degrees and divide it by the order. So in this case, that would be 360 degrees divided by 5, and that turns out to be 72 degrees. And then in numbers 19 through 22, you're going to be looking at a 3-dimensional figure. So first of all, you're asked, does this figure have plane symmetry? In other words, is there a plane that could slice this 3-dimensional shape into pieces where, if we, in this case, if we were to slice it with a horizontal plane, then the top shape would be congruent to the bottom shape, or we could also slice it vertically, where you'd have the left side congruent to the right side. So if you can slice a figure like that into 2 congruent halves, I guess, for lack of a better word, then we would say yes. So yes, this one has plane symmetry. Axis symmetry means that there would be an axis there would be an axis that we could rotate this shape on that axis of symmetry, and it would map onto itself. So this regular hexagonal pentagon would do that. So we're going to say yes, it does have axis symmetry. The order would be how many times it would map onto itself. Well, since this is a hexagon, it's going to map onto itself 6 times. And then the magnitude, will take 360 and divide it by 6. So the magnitude is 60 degrees. In other words, this shape would map onto itself every 60 degrees. In number 23, we're asked to sketch and label a dilation centered at point P with a scale factor of K equals 1/2. So since that scale factor is less than 1/2, your image should be half the size. It should be smaller than your pre-image. All right, so to do that, the easiest way would be go ahead and draw line segments from the point that is the center of dilation to every vertex point of your pre-image. All right, like that. You can use a straight edge if you want to make it a little bit more accurate. And then, since our scale factor is 1/2, let's start by figuring out where O should be. Well, if the scale factor is 1/2, then the distance from P to O prime should be half the distance of P to O. So I'm just going to eyeball it, and I'm going to guesstimate that this is about the halfway point, so that would be O prime. And then let's do the same thing to find out where n prime would be. Well, the distance from P to n prime should be half the distance from P to n. So that looks like right about here maybe. That would be n prime. And then m prime, the point m prime should be half the distance from P to m. That's m prime. And then L prime, again, should be half the distance from P to L. So L prime, I can already tell this is not going to be very good. So you might want to use a ruler so you can actually find those halfway points. And so this would be your your image. Make sure again that you have labeled those image points. Excuse me, this was the pre-image. We ended up with the image. Make sure you label those image points so we know you've done the dilation correctly. Now, if this scale factor had been bigger than 1, then you would end up with a bigger shape where the distance from P, for example, P to O prime would be twice the distance from P to O. So pay attention to your scale factor when you go to draw those dilations. Number 23 will be a dilation in the coordinate plane. So this is a little bit easier to get it looking a little nicer. This one says sketch and label a dilation centered at the origin with a scale factor of 3. So if the dilation is in the coordinate plane, the center of dilation is the origin, then all you need to do is take the coordinates of a point and triple them to find the coordinates of the image point. So for example, B has coordinates 1, 1. So B prime would have coordinates, let's see, 3, 3. So let's plot that point. So 1, 2, 3, 1, 2, 3. So here's B prime, okay? A has coordinates 1, 2. So if you triple those, 1, 2 tripled would be 3, 6. So let's plot that point. 1, 2, 3, 1, 2, 3, 4, 5, 6. So there's where A prime would land. And then C has coordinates 2, 1. So the coordinates of 2, 1 tripled would be 6, 3. So C prime would be at 1, 2, 3, 4, 5, 6, and then up 1, 2, 3. So here's C prime. All right. And then connect the dots. And you should see a shape that appears to be 3 times the original shape. So your image is 3 times the original, and also the distance from, for example, the distance from P to B prime would be 3 times the distance from P to B. All right, and so let's finish up this quiz with number 25. It asks us to determine the type of dilation and then find the scale factor. So we might actually do this backwards. Let's find the scale factor first, and then we can use that scale factor. Depending on the size, you'll know for sure whether it's an enlargement or a reduction. So just a reminder, when you go to find scale factor, always look at the ratio of new over old. So in this case, we have F as our center of dilation. We have W prime and W. So to find the scale factor, take the ratio of FW prime to FW. So FW prime is 8 and FW is 24. That reduces to 1/3. So we have a scale factor of 1/3. Since that scale factor is less than 1, we know that we're looking at a reduction. All right, so I hope this has been helpful. Your quiz will be in class, and if you have any questions before you take the quiz, be sure and ask me.